Good morning. Welcome to PCI's webinar series. This presentation is sponsored by ALLPLAN. I'm Royce Covington, the Education Coordinator and Bookstore Manager at PCI, and I'll be your moderator for this session. Before I turn the controls over to your presenters today, I have a few introductory items to note. Earlier today, we sent a reminder email to all registered attendees containing a handout, which is a PDF of today's presentation. The handout is also available now and can be found in the Handouts section of your webinar pane. If for some reason you cannot download the handout, please email PCI Marketing at marketing@pci.org as shown on your screen. In addition to copies of the handouts, your webinar pane has an area for you to raise your hand. If you raise your hand, you will receive a private chat message from me. All attendee lines have been muted. If you have a question, type it into the questions pane, and I'll be keeping track of your questions to read them to the presenters during the Q&A period. The program content does not constitute approval by PCI, nor does it necessarily reflect the views or positions of PCI or those of their respective officers, directors, members, or employees. Questions related to specific products or publications will be addressed at the end of the presentation. This presentation is non-CEU and not endorsed by AIA. Our presenters for the day are Brandon Botts, Senior Technical Consultant at ALLPLAN. Brandon has 13 years of construction and design experience, with 11 years focusing on precast tilt-up concrete design and coordination. Joining Brandon is Monica Rennick, Technical Manager at ALLPLAN. Monica has over 12 years of structural engineering experience, focusing on engineering analysis and design, managing and interpreting 3D models, and improved workflows. Today's webinar is being recorded and will be uploaded to the PCI website within the next week. I'll now turn the controls over to our presenters so that we may begin.
Great, thanks so much, Royce. Okay, so before we really get going here, I just want to let everybody know a little bit of what we're going to be talking about today. So I'm going to start with just a brief discussion on BIM and the precast and just some industry trends and challenges that we're facing. Then the bulk of today is going to be going through a live walkthrough, and this is where Brandon will show you guys kind of what we're talking about today in the program itself. Then I'm going to just briefly talk about who we are, and then we'll wrap up with some key takeaways and next steps. And there should be some time for a Q&A at the end too, so if you guys have questions, we'll happily answer those at the end of today. Okay, so let's start with our industry overview. And overall, the precast market has been seeing steady growth according to the Grand View Research Center, and that's really expected to continue. Over the next 7 years, overall, the precast market is projected to grow at a rate of 5.2%. And specifically, structural building components is expected to see even higher growth than that. Now, there are some current changes, obviously, in the climate due to what's going on everywhere. People are talking about a potential recession that could be changing these numbers. But what's interesting is that as I've been speaking to our customers, as I've been speaking to precasters and those that work with precasters all over the country, I'm hearing the same thing, that from them, it's been business as usual. They're still seeing just as much business as ever. They're busy, they're working, and things are still progressing. So I think that we really are still in line with this, and there's still going to be a lot of growth that we can all expect in our industry. Now, one thing that I want to talk about a little bit is some of the challenges that our industry is facing. And some of these are universal challenges, but specifically in the precast industry, different challenges that we're facing given the growth that we're expecting, given everything that's going on in our climate. And one of those is labor force. Now, many companies are having a hard time recruiting and retaining new talent. Most drafters have over 10 years of experience, which is great for their knowledge, for their productivity. But as these folks move into other roles, or maybe some of them are nearing retirement, some manufacturers are really struggling to find new talent to fill the gaps. In retaining labor, there's also this need to manage turnover, and high turnover typically comes with high overhead costs. On the other side of the coin, we have efficiency from your current labor force. How can you get more productivity out of your existing team? Or can you justify bringing on another person given your current workload? So these are all things that we need to constantly be looking at and thinking about. Finally, the labor force impacts not only the drafter and the engineer, but the team that he's working with in the shop or the yard. So clear and consistent drawings are required for the guys in the field to build what's properly spec'd. Another major challenge for our industry is the budget. And specifically, we're seeing tighter margins in the construction industry as a whole. So different disciplines are needing to be creative on ways to cut costs, increase profits. And one way a lot of precast shops have managed budgets is through more accurate estimations and inventory control. And more precasters are going to a just-in-time business model, and they're seeing cost reductions from that. But in order for this to work, you need to have accurate preliminary bids, accurate material takeoffs, and minimal errors to reduce cost and time wasted on errors. So with just-in-time manufacturing, you can't afford to wait around on a part of something that went wrong. That kind of leads us into the next challenge, which is involving time. Now, this is something that we're all accustomed to: tight deadlines, tight schedules. Our manager saying, I need that drawing yesterday, and you're scrambling to get it done. Drafters and engineers need to be faster than ever in today's technological age. Another factor that comes into that is the demand on time versus workload. So could you bid more projects or expand into a slightly new segment if you felt your current labor force could handle it? Maybe that extra job wouldn't validate a new employee, but it could mean some higher earnings for that year, maybe some profit sharing for everyone. These are things that managers have to take into account, and they're things that the labor force, us as the drafters, as engineers, also have to be aware of. Is, can we go to our manager and say, hey, look, I probably could take on a little bit more, or no, I'm really strapped. We need to concentrate on what we have now. And then the last note here on delays from idle time, and that goes back to the budget as well. That could be idle time in the yard, waiting on a part or waiting on drawings. It could be idle time on a project for a drafter to wait to hear back on shop drawing reviews. I even consider some manual tasks to be idle time. If you have to input data manually into a machine when there could be an automated way, that's really time wasted. Finally, the last challenge I want to address today is that of competition. And the precast industry is competing on projects against new construction options that are popping up every year. Different modular options, different materials, and so on. So space, time, scope, appearance, all of these factors really come into play on whether somebody goes with precast for their next project. So how can we address some of these challenges? There are a few common threads that weave through what I've discussed so far. Commonalities revolving around time and accuracy, and also modernization. So many of these points can be addressed and improved by automation. Now, the term BIM has been around for a long time now, and I think we're all pretty tired of hearing about it and all the benefits that it brings. I think we all know what it is, we all know what it contains. But something that I think we failed to focus on as an industry as a whole is really that automation side of BIM. So it's not necessarily the modeling that's going to help us move forward. It's the information and the way that we can harness that information. There was a study that I found that was conducted in 2015 that looked at several precast shops in Asia, and they looked at the impacts of automating their shop drawing process. Now, what they found was really interesting: an increase of 38% in productivity and 380 man-hours of savings. And that's just one piece of the puzzle. It's a significant piece of the puzzle, but really they got a lot of improvements for that one piece. Now imagine if you could stack on top of that automated reports, automated bill of materials, all done through a slick piece of software that really gets you excited about that next project and how to pull it all together. A modern piece of software that you want to model in, that you want to pull this information out of. So now I'm going to finish talking. I'm going to pass it on to Brandon, who's going to show you what we're talking about here. And we're going to take a look at our program plan bar. All right, so go ahead, Brandon, and take it away.
All right, thank you so much, Monica. All right, so you guys can see here that I have this building that I started. It's pretty much a parking garage in the back and an office building in the front. So the office building, it's comprised of just precast beams, precast columns, hollow core slabs, and precast walls. And the parking garage is just double T's, beams, columns, and some walls as well. But you can see there's some major components missing. I have a wall that's missing in the front and some hollow core in the middle bay that we need to work on as well. And as far as the parking garage, I left a bay out of double T's that we're going to work on as well. First things first, we're going to hide the parking garage. We're going to just put it in the background, and we're going to mainly focus on the office building for now. We're going to focus on that wall and that bay of hollow core. So first things first, we're going to work on the wall. And to do that, we're just going to focus in on the wall area. And then we're going to go to our wizard, and we're just going to choose our wall command, and we're just going to go with an 8-inch wall. I think that's what the others are. So we're not going to worry about the properties now, how it's viewed and the height and everything like that, because we're just going to match that later. So I'm just going to go from point to point, place that wall in, and then we're going to go to our match properties tool. So that way we don't really have to worry about, you know, what the wall was before. We can just model it in, select the match command, and match everything. That way it's up to date. It's you know exactly what we had already. All right, so got our wall in, and now I'm just going to add a couple openings in. Now I'm actually just going to grab some openings that we already have, and I'm going to mirror those over. And to easier do that, I'm going to filter out the openings. They're going to be an architectural opening. We're just going to go to our filter command, choose the window opening, and that way we can select that whole area and only grab the openings and not everything else, not the reinforcing, the lifters that I already have in those panels. So as soon as I have that, I just simply mirror it over, choose my access point. I can either choose an access point or draw my own access point, which I just did there at a 45. So I'm going to go ahead and I'm going to mirror these openings over to the other side as well. And this time I'm just going to grab that access point. I'm going to grab the center of that building. That way it mirrors it over exactly how we wanted. All right, so we have our outer openings in, and now I'm just going to add a bigger opening in the middle of the wall. That's going to be our entrance opening. And to do that, I'm just going to go to our properties of our door opening, and I'm going to specify the width and the height. For the width, I think we'll go with 8 foot wide. That way it's the entire width of a panel. And I'm going to go with 20 foot high. It's going to be a large, nice opening for our architectural entrance. And I'm going to choose a center insertion point. That way we can choose the exact middle without having to fuss around. We just choose the exact middle, place it in, and we're good to go. All right, so we've got our openings in our wall, and the next step is we're actually just going to go ahead and we're going to turn this into a precast wall. So currently we just modeled it in as an architectural wall, and now we're going to just convert that to a precast wall. That way you have all of your attributes, everything tied into it as it should be. So to do that, we're going to go to our precast tool, and you can see we have multiple tabs in our precast tool in the palette, and we're going to start from the left to the right. So the left tab is, you know, where we just convert it to that precast wall. And then you can choose all of your different attributes and types in here. So first, we're going to choose what type of wall it is, whether it's a solid wall or a sandwich wall or any other wall that you have. And then you can choose your factory. This is very important. If you're a precaster that has multiple different plants, you can actually set up all their settings for each plant differently in your precast catalog. Now you'll hear me talk about this precast catalog quite often. These are where all of your standards and settings, everything that your shop is used to is going to be set in that precast catalog. So like I said, you can choose your plant, all of your settings adhere to that plant. As soon as you choose that plant, the rest of your settings as you go along are going to be according to that specific plant that you choose. So we're going to go with my Brandon's factory plant. And then we're going to go to the rest of the attributes here. These are all your additional attributes that you can add in, such as your finishes. I just have a steel form finish and an acid edge going in to my form side and top and form. And again, you can add any finish you want and select that here. And any other additional attributes, such as dunnage points or really anything that you want to add in here. It's just going to, as soon as you enter it in here, it gets tied to that panel. So you can bring that information back at any point. So we'll go ahead and we'll select that wall, and you can see it just created one large wall. It's 286,000 pounds, a little too heavy for cranes. And as my son says, I don't even think the Hulk can pick that up. But okay, so it's really heavy. And now our next step, after we turn it into precast elements, we're going to go from left to right. The next one is the corner connections. So we're going to create corner connections out of each of those corners. So right now, they're just basic corners. They have no, they're not tied to each other. So as soon as we select the walls, it's going to actually tie them together, and we can create the different joints that we need. Right now, it just defaulted to a lap joint, but you can change that. I'm going to show you a quick mitered corner. So you can see the miter comes in nice with the cork, and you can define that cork size as well. We're just going to change it back to the lap, and you see that worked out quite nicely. So we're just going to move on to the other corner. We're going to highlight those two walls. And this lap, that's not exactly how we want it. So I'm going to switch that back to our other lap. So it changes that lap direction, and that way it looks how I wanted it to look. All right. So we got our corner connections in. Next step, we're going to panelize the wall. We're going to turn it into individual panels for the entire length of the wall. And there's two different ways to do this now, that you can either do it maximum element length or equal element length. So the equal element length does exactly what it sounds like, right? It takes that entire length of the wall, and it breaks each panel into equal element lengths according to your maximum width, right? I have a maximum width of 711.5, so it's not going to exceed that. It's going to go as close to it, but not exceed it. So equal element length was 7.5 or something like that, then it would do equal 7.5s the entire way. But for this, I'm going to actually go with the maximum element length, and that's going to be 711.5 because I have a standard bed that's 8 foot wide, and I want to adhere to that standard. So most of mine are going to be 711.5, and it's going to stick a skinny panel at the end for us. And you can choose to do divisions and openings or not. If you choose to not have joints in the openings, you can specify your minimum leg distance. I have it set to 8 inches, but actually I'm going to turn that off because I like to just do things my manual way, not manual way, but just a sense to where I can go back in and modify it myself, because I want to show you that here. So I'm going to go ahead and I'm going to select the wall, and it's going to automatically break that entire wall into those panels as we specified. They're going to be 711.5, starting from left to right, with a skinny panel at the end. Now you can see it started out quite nicely with my openings, so they were spaced accordingly, but then at the end you started to see where you got the joints in the openings. Now that's not how I want it, so I'm going to go back and I'm actually going to modify that right now. So I'm going to go back to our second tab, and I'm going to add manual joints in now. Now we actually call them mandatory joints in Plan Bar because when you place these mandatory joints, all of your automatic joints that were placed are going to be based off of that mandatory joint. So you can see I'm going to place a joint right on the other side of that opening, and all of the other joints to the right of it adhere to that mandatory joint. Now I'm going to place another one on the left side of the opening to create a spandrel panel. You can see it automatically broke that up, and it created that spandrel panel above the opening. So we still have to deal with the joints in the opening on the right side of that wall. So I'm going to go ahead and I'm going to do that now. So I'm going to go ahead, I'm going to go back to our joint tool, and my spacing for the windows, I believe they're perfect at 16 foot, so they're good for the 8 foot wide panels. So I'm going to go ahead, I'm going to choose to place this joint 1.6 foot below that opening to create that perfect panel joint where we wanted it, right? So it's looking pretty good. And now I'm going to add one more joint, just because you can see at the left of the big opening, there's a skinny panel, and to the right of it, there's a larger width panel. And that's not exactly how I want it to be. Yeah, it would be fine, but architecturally, I think I want it to look a little bit nicer, to make it a little more even. So I'm gonna place one more joint in just for my purposes. All right, so now we're good. I think we got equal panel joints throughout, and it's looking really nice. So I'm gonna do one more thing to this wall before we add lifters and reinforcement. I'm actually gonna raise the height of the center of the wall, the center 5 panels around that large opening. Now, you can do this multiple different ways, but instead of breaking up that wall, we can keep it one wall, and we're just going to add an additional plane to that area. Now, that plane can be any height that you wish. I'm just going to make it 2 foot higher than my other wall heights. That way, we can just make that entrance a little more architectural friendly, and actually structurally as well, because we need to get the top of that wall above your hollow core plank as well. So we're just going to raise that area of those 5 panels, and we basically just choose that, define the area that we want to raise. We select it, and then all those panels automatically update per that plane that we chose. All right, so that was really nice and easy. You just decided, where you wanted it to go, and it followed exactly how you wished it to do. Perfect. So now the next step, the fun part, we're adding in all of the reinforcement, lifters, brace inserts, and anchorage points if you want it as well. So that's going to be our last tab in our precast wall tool. So we go to our last tab, And then here, I'm not going to go through every aspect of this entire palette, but I'll go through the main points of it. So first, we're going to do our reinforcement. Reinforcement, basically, you select all of your steel grades that you wish to use, and these can be defined as well. You set those up for how your standards are, and then you go with your reinforcement. What reinforcement you want to use? So I typically use my reinforcement types. My reinforcement types are your typical strand patterns and your bar spacing, your horizontal bar spacing as well. Those are all saved in your Precast catalog, like I mentioned earlier. A Precast catalog saves all of your standards, all that you're used to, all of your strand patterns that you're used to. You define them there, you save them as your typical name, and then you define them here. So I'm going to select my type 2 strand pattern for my reinforcement. That's going to be a 1 foot verticals and 2 foot on center horizontals. The next step is the reinforcement around openings. You can define how that's specified as well. But I'm going to go ahead and I'm going to load my favorite actually. So my favorite that I loaded in is my typical reinforcement and lifting patterns that I specify for my 8 foot wide panels. And that's going to be no reinforcement around openings, but everything else is going to be set. And I'll go ahead and I'll add reinforcement around my openings after the fact, just to show you the a little bit more manual way, but a nice easy way. So these are my bracing inserts. You basically can go off of a fixed height, that's 25 foot above the bottom of the panel, or you can do a percentage of the height. You can do 66% of the panel. That's typically where brace inserts like to be. And then you specify which insert you want to use. Now these inserts come from your library. We have default ones, but you can also create your inserts that you define and place in your library, and you can choose them there. So these are your lifting inserts. Your lifting inserts is, again, so many different options for your lifting inserts. You can have side lifters, top lifters, back lifters, and you can specify how those come into play right here. Now for this example, I'm gonna do side lifters and top lifters, and I have it set up so where if it's under a certain amount of weight, it only adds 2 side lifters and 2 top lifters. But if it's over that certain amount of weight or length, it's going to give 4 side lifters and 4 top lifters. Again, those inserts pull from your library. You just specify which inserts you want, and then it comes in when you specify the wall. So we're going to click on the wall, and all that information is going to be placed into those individual panels as we specified. All the reinforcement, all the lifters, and all the brace inserts get placed automatically for you, right? And the lifters are based off of center of gravity too. So that's another step that you don't have to do. Everything gets placed in for you. The time reduction is amazing. See, look at that. So I'm zooming in a little bit, and you can see those lifters being placed in exactly how we want it. And you can specify the distance away from openings. You want those lifters as well, and that's what it did there. And you can see the spandrel panel. That spandrel panel is lighter, it's shorter, so it only added 2 lifters in the sides and tops, and not 4 like the remainder of the panels. Wonderful. Now that just saved so much time. So placing it in automatically all at once for you. It's great. All right, so now before I create shop drawings out of those panels, I'm actually just going to create a quick elevation view just to show how easily it is to create these views and then to be placed on your drawing sheets. There's many different options for this as well. You can choose a hidden view or a wireframe view where you can see everything, and you can filter stuff on and off. You can filter your reinforcement on or off. I'm going to keep it on for now, because I'm going to add some reinforcement. This is where I was talking about adding some additional reinforcement around the openings. But you can see my elevation automatically added all of these dimensions in for you. It added the overall dimensions, it added the opening dimensions, and it added each panel dimension and panel joints. So all of that is already done for you. That's another step that you don't have to do manually. And it's accurate too, because it reads all of those edges for you, and it places those dimensions in for you. All right, so now I'm going to go do what I said. I'm going to add in some reinforcement around the openings. And we're going to use our cool tool that we have that basically you just select that opening reinforcement and then you define the parameters for that, whether you want stirrups around it or just longitudinal bars and diagonal bars. Now, for where I come from, we typically just put some diagonal bars and a couple of longitudinal bars. So that's what I'm going to do. And you can specify the amount of bars and spacing as well by these parameters. But I'm just going to go ahead with 2 on 2 longitudinal bars and 1 at the sides, but top and bottom. So you just go ahead and you hover around the window and it recognizes the shape, and you click inside of it, and then it automatically adds that reinforcing into that opening for you. And when you specified your covers, as long as you specified your covers accurately, it's going to come in with no clashes, and it's going to be perfect for you. And you can visually see that right here. Visually see there's no clashes, and you're good to go. All right, awesome. So the part that you've all been waiting for are automatic shop drawings. Now, I used to hate this part as a drafter, but it comes in, it's so easy now, right? You just select your element plan tool, you select the panel in which you want to create that shop drawing out of, and then you select your template. And these templates, we have predefined templates, but you're probably going to want to customize yours to make it look how your company wants. So you just choose that template that you created, and then automatically spits that shop drawing out exactly how you had it specified. So this template that I have specified, everything comes in dimensioned. Now, my inserts have a separate dimension line. They can be dimensioned separately. I have that listed. My bill of materials came in automatically. I have 8 lifters and 1 brace insert. All of that information comes in automatically for you. That's another step that your drafters do not have to do. And you can see the lifters, since my windows weren't perfectly centered, the lifters are a little bit off-centered as well. It goes off the center of gravity. That's another step that we don't have to do manually. All right, so I'm going to show you one thing that's really intuitive about our shop drawings that I love, and that I'm sure everyone else is going to love as well. Besides the fact that everything comes in automatically for you, all that information, but the fact that we can actually modify the shop drawing itself and everything else gets updated. So I'm going to do something really simple. I'm just going to copy this brace insert over, and once I do that, you can see it gets updated in the model to the right. Automatically added it there. And then I'm going to go to my bill of materials in the shop drawing, and you can see it automatically got updated there as well. Now we have 2 brace inserts. So it updates everywhere. Reduction of errors is key. And to do this in a 2D sense, you would have to update this everywhere. In our software, you simply copy it over in the shop drawing, and everything else gets updated. Single source of truth. All right. Awesome. So next step. We got our wall done, and now we're going to move on to our hollow core slabs. So we're just going to go back into our building structure, and we're going to just hide a couple things to make it a little bit easier to see. So we're going to put our walls in a reference only mode instead of active. We were in active mode because we were actively modifying that, but we're going to put in a reference only mode so we can't modify it, but we can still see it. And then I'm going to hide a couple other items as well, just to make it a little bit easier to see. And make our slab level 2 active because we're actively going to be drawing in it. All right, so you can see this center bay is what we're going to be working on, and it's going to be bearing on the 2 precast beams that I have placed in, and it's going to be going around those columns. So to do this, we're just going to go up to our precast slab tool. Now our precast slab tool is a little bit different than our wall tool. Basically, you have a dialog box that pops up, and you can choose between your different slabs that you have. Typical ones here are going to be pre-stressed hollow core, double T's, or solid slabs. We're going to go with our pre-stressed hollow core for now. And then you can go into the properties. You can define all the different parameters for it. So I have a couple different hollow core types set up in my catalog, my different thicknesses. I'm going to go with my 12-inch thick hollow core type. And for my 12-inch thick hollow core type, I have specific cores that I defined in my catalog as well. So I use typical Spancrete cores. So I actually go in my catalog and I can define that typical shape. I can define the spacing that I need for each particular thickness and type of hollow core. So once I have that defined, I can go in, I can just check to make sure all of my other settings are correct. Now this I have to recommend for me to have a 2-inch lap joint for the longitudinal sides of the hollow core. But for this sense, we don't want that. We're going to be inside of our precast wall, so we want a -1-inch lap. So that's going to give us a 1-inch joint in between the hollow core and the edge of the wall. And then your maximum width, that's just saying it can be anywhere between the -2-inch for the minimum and the 0 for the maximum, in case it needs that extra like 1 1¼ inch or something like that. We're going to give it the go ahead to do that. All right, so once we have all of our parameters set up, we can either just select inside this empty area and it's going to recognize the area detection. It's going to recognize that area that we want. Or we can do what I'm doing right here, and that's just going to be polygonizing it. Actually, I'm just drawing corner to corner, and it's going to recognize that rectangular shape. But you can trace out any shape that you want, and this hollow core is going to follow that shape. But as I did the corner to corner, recognize the rectangle, and ALLPLAN bar automatically recognizes the short span. It's going to recommend that short span, but you can simply click the button and change it if you want. But once we have that shown how we want, we can then come back and we can specify if we want to add a joint or delete a joint, if that wasn't exactly how we wanted it to look. we can add that here just like we did for the walls as well. And then we're going to specify our strand pattern. I have a couple different strand patterns set here, and we're just going to go with my 1207 strand pattern. Again, that's set in your catalog, the spacing and size of strand and whatnot. All right, once that's done, it places all that information into that hollow core slab. Everything's tied to it. All that information is there. And you can see I actually have a setting in my columns. I have a recess attached to that column, so my hollow core actually notched around it perfectly fine with no problem at all. So it's looking pretty good. As of now, we got it placed in, and I have my inserts. Actually, that's another setting that I have in my catalog. I have welding inserts at the ends of my hollow core, and that's going to be placed in how you specify it. I have it placed in, I think it's the 2nd and 5th core, and that just comes in automatically. That's just a setting that you have. You can have it whether it's a plate or a DAP out that comes in automatically. You can have that specified, and it'll come in automatically for you, but it's not set in stone. I'm going to come in here. I'm actually going to move this embed over just to show you, it's not always set in stone. You can come back and modify it to be exactly how you want it. All right, so I'm going to actually go ahead and I'm going to add an opening, and this opening is actually going to be a large opening. It's going to be a 4-foot wide opening, which is going to take out that entire piece of hollow core. So just because I want to show you how PlanBar interacts with it and how this works. So once I place this 4-foot opening, it's not only going to cut that piece of hollow core back, but it's going to give it an extra piece of hollow core on the opposite side of it. So once we do it, you can see it breaks it apart, gives it another mark number, another piece on the opposite side of it. So it's looking really good. It worked out really well, except, right now we're just using sky hooks to hold these hollow core up. So we're going to have to come back and we're going to add in a hanger to it. So to add that hanger to it, we're going to go to our fixtures. And these fixtures are connection inserts or headers, anything in that sort of sense. We call them fixtures. But these are all just ones that you can define. You just model it in 3D, you define it in your library, and then it can come in automatically. So this particular hanger fixture actually has P2s on the side of it. It's going to be a group fixture. So it has a hanger, and then it has my welding inserts that come into the sides of it that go into the plane. So once I insert it where it belongs, it's going to read that precast height, and it tried to place it on the bottom, but we can just go ahead and we can select the 0 inches for the top height. So it places it in at the height that we would like. All right, so it looks like that hanger got placed in where we wanted it on the one side, but now we're going to have to mirror it to the other side. So we got it placed in where we want. So now we're just going to basically highlight all the inserts, the group fixtures that we wanted. And then we're going to mirror it over. And for this, I'm going to choose an access point. I'm going to go to the midpoint of the opening, and I'm going to make that access point so we know we can define where it mirrors it upon. All right, now you can see, since I did have embeds placed in the top of this hollow core, we can't just place inserts in hollow core, right? We're going to need to open that core up and fill it shut. And that's what we're going to do here. I'm going to add a solid fill to those cores. So I'm just going to select how I want that solid fill to be represented. And then I'm going to define whether I want it to be along the entire length of the hollow core, or if I want to define that particular shape I want to fill the cores with. And I'm just going to define that shape. So I'm just going to make a rectangle of the area that I want to fill. And then it's going to automatically fill that core for us. Now, it looks like I have a surface in my hollow core, and the transparency is not set too high. So I'm going to go ahead and change that really quick, just so it's easier for you to see, because you can't really see that very well. So I'm going to go into my surfaces. I'm going to make the transparency a little bit higher, and I'm going to take away that surface just to make it a little bit easier for you to see that solid fill. See, you can see it blocks out that exact spot that we specified. Now, this isn't set in stone either. You can modify it after the fact. You can stretch that grout fill. You can move it. You can copy it. Right now, I'm actually going to mirror it to the other side because we need that grout fill on the other side for those other inserts as well. So we're going to mirror that grout fill over, and it automatically places it in as we wanted. And as soon as it has that edge, you don't even have to encompass that whole core. it just, as soon as it touches that core, it recognizes it and it fills it in for you. So I'm going to show you one more really neat thing that is really beneficial, I believe, and that's called our definition ranges. So say you have a point load on these hollow cores. Say there's a really heavy piece of equipment that's going to be setting on this hollow core. You can go ahead and you can define that here. That way it doesn't get forgotten about and it's always set here. So I'm going to just define that area. Again, you can trace along that path of the shape of that equipment and you can define that here. So I'm just going to create a rectangle. And then I'm going to go into our palette and you can define the properties of it. So for the properties of that definition range, you can actually set in the actual loads that are going to be in it. You can set the loads, you can set, particular attributes, anything that you want to tie to it, you just specify here. But I'm just going to go into our reinforcement and I'm going to add a different strand pattern for this because it is a heavy load. So I'm just going to change it from a 7-strand pattern to a 12-strand pattern. So as soon as I specify that strand pattern, it gets tied to the panel. And then I'm going to come over to my plan view and I'm going to place a label so it's also letting us know that it's going to be a different strand pattern. And then once I do that, the strand pattern gets updated in the model as well. You can see the ones to the side of it are a 7-strand, and then my label says 12-strand for those particular ones that range is touching. All right, and that gets updated for your shop drawing as well. When you create those shop drawings, that strand pattern will come in with it. And that's actually what we're going to do here. We're going to create another shop drawing of our hollow core, just simply using the ALLPLAN tool, selecting your template, selecting the panel, and then the shop drawing gets automatically generated, just like it did for our wall panel. All of our bill of materials come in. Any attribute that you define, that you want to come into your shop drawing will come in here as long as you define it. The quantity, see there's a quantity of 1 for this because it is different. It has the notches in it around the column, and all of those dimensions came in as well. And now this is a simpler shop drawing because it's just hollow core. I just have some dimensions. I have the cross section coming in as well. But you can have them show exactly how you want, completely customizable. So I think our office building is essentially done for now, for our senses, our purposes. So we're going to go back to our building structure and we're going to hide our building, our office building. And now we're going to bring back our parking structure. And we're going to make our slab level 3 active. And that's where we're going to add that bay of double T's in. So once I get this set up, make it a little bit easier for you to see. Now you can visually see that's the bay that we're going to be working in. That's the one that we're missing that row of double T's for. And that's what we're going to be working on now. It's going to be similar to our hollow core, but a little bit different. We're going to go to our precast element tool, and we're going to use our DT placement. Now we're going to use our DT placement because we're going to be able to warp these double T's and do a lot of different things to them. So first, we're going to set our heights, and those are all based off of the elevations, your planes that you set up. And then you define your placement regions. So our placement region for our first line is just going to be point to point, because this is a really simple point to point region. And if there's any notches in the way, any columns in the way, it'll automatically notch around those for you as well. So we can just do point to point there. And then for our second placement region, it's going to be a little bit different because our second placement region, our line is going to be based off of a precast beam. We're going to be bearing on a precast beam, and then we're going to be bearing on a wall ledge. So we're going to have to go in and out a little bit. And then we're going to specify the drop points as well. So this point that I'm selecting now is a drop point for drainage. So that's the point we're going to be able to lower and raise. I mean, you can actually lower and raise any point that you define here. But if you forget to add a drainage point here or another point, you can always come back and add it or modify it later. So it's not the end of the world if you miss something right here. Then we'll just go ahead and we'll select our last point of that placement line. And once we do that, it automatically places in these double T's for us. Now, it remembers your last placement that you used, and my last placement was my 12-foot wide profile. I think it's a 12-foot wide and 28-inch deep profile double T. So it automatically placed those ones in for me, and it looked like it worked out really well for this placement. I think they're 25-foot bays, and so I don't need to modify the widths of any now, but I'll show you that a little bit later as well. I'm going to go ahead and hide the rest of it and just make this level visible, make it a little bit easier to see. So our next step, we're going to just modify this a little bit. I'm going to show you the drainage point. So our point, I zoom in here, you can see it labeled at 2.3, that insertion point that we go. So it's going to be placing line 2, and it's going to be number 3. So in our palette, we can just go to that number 3, and we can lower it. I'm going to lower it a drastic point, 6 foot down, just so you can visually see that warping capabilities. So your placing line 1 stayed the same, but your second placing line added that warping feature into it, and your double T's warp accordingly. But I'm going to change it back to a 1 foot, a little bit more reasonable, a little bit more realistic. And then I'm going to come over here, and I realized that this placement line isn't exactly how I want it. Remember how I said you can come back and modify the placement, and that's what I'm going to do here. I want it to be, you know, a little bit different. We're going to go to a -2 inch. That's not what I want, so I'm going to change it back to a 1 inch. And now that double T has enough bearing on that ledge that I want. Now, like I said, these double T's worked out perfectly for this bay, but we're going to modify that in a minute. And also another feature that it adds in are your connection inserts. So currently for this setup, I just have the 3 connection inserts. I have the ends of bays, I have the joint connection inserts, and I have the lifting inserts coming in. Now, again, you can define these, comes from your library, wherever you choose. That insert comes in from your library, and then you can specify the different spacing as well. So I did the ends, and now I'm doing the connections, the joint-to-joint connections. I'm going to change that to a mini V, and I'm going to make it a 5-foot spacing as well, just like the ends of bays. And then I'm going to go down to my lifting inserts. Now, the lifting inserts, again, you pull from your library, you choose which lifting insert you want to do, and then you specify a distance from the end. You know, double T span from end to end, so you basically just want a distance from the end. You can specify that here, and it places it in as you want. All right, so now I'm going to go in and I'm going to modify the widths of these. Modify the widths of the double T's at the end of the bay, just to show you the capabilities in case that the typical profile that you're trying to use doesn't work out for that bay spacing. So to do that, I'm just going to highlight that particular double T I want to change, and then you can specify which side of the flange you want to cut, whether it's the left side, the right side, or both sides, right? So for this, I'm going to choose both sides. And I'm just going to mess with this a little bit, mess with the widths just to show you how this reacts to it, how it works. So I'm going to change these a little bit. And, you know, every one that I want to change, I just click on the grip handle and then it highlights it over in the palette, and you can change those particular widths. And once that's there, you can modify those widths however you want. And once I get down to a certain amount of width, you know, that's low enough, it's going to automatically add that extra double T at the end because it recognizes your overall placement line, and it adds that other double T for you automatically. But I think I'm going to just make it work out evenly. So I think it's 9 foot wide double T's that adds an extra one at the end. And that worked out well. So instead of 4 12-foot wides, we went with, 3 12-foot wides, we went with 4 9-foot wide double T's. And all the mark numbers get updated accordingly, of course. So it's really simple just to modify the widths. It really gives you that custom ability to modify widths and really make that profile however you want. So now we're going to reinforce these double T's and create an unwarped double T state at the same time. So what we're doing, we're actually creating two different placements. One that's warped, that way you can show in your model, that way your ledges can all be accordingly to that warped version. And then our second version is our unwarped reinforced version. So you have both. You can always revert back to one or the other, and they're always synced. You don't have to worry about that too. So we're just placing in our reinforcement parameters right here. Right now I'm going to place in, actually I'm going to load in my favorite, but that places in a rebar mat at the top of the flange. It places in a row of strand in the stems and mesh at the ends of the flange as well. So again, you can save and load favorites for those. You have your typical favorites. You can just save and load those in at any point. And then you just specify which double T's you want to add that reinforcing to and create the unwarped state to as well. And then you hit create, and it automatically adds all of that information into these double T's. So once that's done, we're going to visually see all of that reinforcement in here. And I'm going to go ahead, I'm going to hide that warp state. That way we're only looking at our unwarped version that we just created. And I'm going to come in. I like to show this just because I think it's really cool how the double T's actually step instead of warping, because this is how it's actually going to be fabricated. This is how it's actually made in the plant. And then once it gets set in the field, then it creates that warped state. All right. So now we're going to actually turn these into precast elements. And you're probably thinking, well, it's double T, it's precast. Yeah, it is. But in flan bar sense, once you turn it into a precast element, it actually ties all of the information that you have in these double T's to that precast element, such as the reinforcing, the lifting inserts. And like I'm doing right now, I'm going to specify special attributes to it, such as the concrete grade, the finishes, that sort of items. That all gets tied into that precast element. That way, when you create your shop drawings, it all comes in as well. So we're just specifying that it's going to be a double T, and we specified the concrete grade, and then we're going to go ahead and we're going to just select all of these double T's, select everything that you want to turn into a precast element, and then it's going to automatically do that for you. And like I said, it's turning all of those elements inside the double T into that particular element. It's tying it to those. So once we have that done, they're turned into precast elements. Our next step, again, is creating those automatic shop drawings. And it's the same basics, the same thing that we did for the wall and the hollow core. Select the element plan tool, select the precast element you want to create a shop drawing out of, and the template, and then selecting OK. And it's automatically creating that shop drawing for us. And you can decide how it looks here as well. If you want to show the reinforcing, you can take that off or on. You can turn those on or off. Just make it a little more clear for you as well. But again, everything is dimensioned. Everything is how you specify it in your catalogs. If this isn't how you want to show your shop drawings, it's not how you typically see, don't worry, because we can make it show exactly how you want. All right, so before I leave you, I'm going to show you just two more things. Really, it's going to be pretty quick, so don't worry. I'm actually going to go back to our building. I'm going to hide our parking garage. I'm going to go back to our office building, and I'm going to generate a couple different reports for you. These reports are very nice for quantity takeoff or just for you guys in the plant, just so they know exactly the material that they need, and really anything. So you can create these reports out of anything. They're completely customizable. I'm going to create one out of my precast elements and just out of the walls. So I have my walls layer active. I'm going to choose my precast elements report, and it's going to select all of these walls in my active file. And now, once it's generated, you can see how I created this report. So my report shows a preview of that individual panel to the left, and then it gives all of the attributes about that panel. It gives you the mark number, the quantity of the mark number, the overall dimensions, the cubic yardage, and the steel weight as well. So you can see it gives you a total sum at the bottom. We have 256 cubic yards of concrete for the walls in our office building. Now, isn't that amazing? Like, seriously, this is so beneficial for all of your people to use. Your estimators, the shop guys, and everybody. Is just really useful. The next report I'm going to show is the list of fixtures. So that's all of our connection inserts. So it's just going to give you a detailed list of the fixtures in here. And I didn't have too many in our walls, so it's basically just going to show our lifting inserts. So there's 146 RL4s, and there's 19 B2s, which are my brace inserts. Now you can see below it says the shaped linear fixtures. Those are going to be all of your reveals and your corbels, your ledges and stuff like that. It's going to bring all those in as linear fixtures, and it gives you the total length of those. So you can see there's 12-inch corbels. I have 117 feet of those. All right, one more schedule, and that's just going to be the reinforcing schedule. So right now I'm just going to rearrange all of my bar marks. It's kind of what it's doing. It's recognizing all of the bars that are same length, same size, and it's giving them the same mark number. So once I do that, I can go into my reinforcing schedules, my legends is what we call them. And this is going to be just a typical reinforcing schedule. I didn't create this as a default one. It's going to give you all of your bar shapes, your lengths. So you can see we have 77 number 5s that are 42 foot long, and all of the rest of the reinforcement that are in these walls comes in automatically. And again, completely customizable. If that's not how you want it shown, you can create your own schedule that brings in that information as well. All right, before I leave you, I'm just gonna spin this model around, make it look pretty. I'm actually gonna add a surface to it and remove the transparency, just so you can see the concrete in it and get it ready to be rendered. I just want to remind you guys that we do have a great rendering engine in PlanBar. That way, I know it's, precasters, they don't really go for that pretty stuff, but we can do that as well. Customers like to see what they're getting, and with this ability, you can show them exactly what they're getting, and it's good for marketing purposes as well. Once you have the whole building set up, and you can add, different surfaces for each element as well. Once you have that set up, you just hit the rendering button and it'll give you a complete rendering for you. All right. Well, that is going to be it for me. Thank you very much, everyone, for listening. I'm going to hand it
Okay,
back to Monica now.
great. Thanks so much, Brandon. Um, that was great to see. So I'm just gonna wrap up a little bit here now. Really quick, who the heck are we? You've been listening to us for the last hour, but we didn't really say who we are. ALLPLAN, we are an AEC software provider, and we've been around for over 30 years. You've heard Brandon mention PlanBar, and that's our precast solution within, the ALLPLAN software. We are relatively new to the US, so you might not have heard of us before, even though I'm talking to more and more people and they're saying they're, hearing our name more and more. So we're relatively new to the US, but we've been around for a long time in Europe, Asia, other countries. So we were founders of the open BIM platform and concept. So we very much believe in communicating with other software and using the right tool for the right reason. And so that's a great thing about just ALLPLAN in general. So like I said, although we're new here, we have a big backing, a big support, lots of resources at our disposal. So over 400 employees in 9 countries, lots of users, lots of languages. So, we have a lot of bang behind us. So really quick, just to summarize what we've been talking about here today, I just want to reiterate and highlight some of the things that Brandon touched on and just kind of bring it back to those challenges that we talked about at the beginning. And the first is that automation. I just want each of you that are in practice right now to just take a moment and think about how long today does it take you to go through and break up your wall panels and determine their sizes and do some calculations on their lengths and is this going to fit and how does this go together, and then just think about that one touch moment that Brandon asked PlanBar to just fully automate it for him. And then what's important for everyone to remember when they're choosing a software program is, can it automate? Yes. But then does it give me the flexibility to stay in control? After it automates, can I go back and make the changes that I need? And we saw that was definitely there. The other part of it, reinforcement. Again, you can probably draw some lines really quick to represent your reinforcement. You can, get it out the door quickly. But do you have the information tied to it? Can you then pull a quick report of all of your rebar? Can you, send that down the line so that estimating and purchasing can do what they need to do? And also, can you set some of that up ahead of time so that it does automate the rebar modeling portion of it? That's a huge part of it too. The shop drawings, I think that one just speaks for itself. I mean, the automated shop drawings is just key to productivity, to saving time, to eliminating errors, to having it linked back to the model. So many benefits there that our customers are seeing. Bill of materials and quantity takeoffs, same thing. Can you just quickly pull a report of what's been modeled? I spoke to a customer last week, actually, who they have a guy whose job is to go through all their drawings and count up all their inserts and then calculate all their panel weights and then, plug and chug that down the line to do whatever he needs to do. And it's just a part of his job that he hates. And so now they're implementing ALLPLAN and he's starting to see the benefits of just one click, bam, he exports it to Excel, and they're really excited about what that's going to mean, for their shop in general. Same with reports. And then we didn't talk about this today, but we can automate even further, send information directly to the machines if you guys cut your own rebar, to maybe like a Schnell machine, to, some other things that you might have around there. Okay, so that brings us, to the end here, and thank you everyone so much for spending your morning here with us and learning a little bit about who we are and what we do. We really appreciate your time. If you have any questions, feel free to reach out to us at info.us@allplan.com. And I think we're going to open it up to some questions now.
Thanks, Monica, and thanks, Brandon. That was a great presentation. We do have some time for Q&A, and we have a few questions lined up. This first question is actually a two-parter, and the question is, how easily does this BIM model merge with models from other programs like Navisworks, and are there extra steps needed to have models merge correctly?
Absolutely. Yeah, go ahead, Monica. I'll let you have
Oh,
this one.
okay. Okay, yeah, no, I was gonna say that really ties into that open BIM
Hmm.
platform that I mentioned. We very much believe in communicating with other platforms because every discipline's using something different, right? The architect could be using ArchiCAD, and then the engineer could be using Revit, and then you're using PlanBar, and they all need to talk to each other. And so we very much believe in that. There's a lot of different files that you can import, export out of Plan Bar. You can, we have some ways where you can see what's changed in those drawings. We also have a cloud-based solution that we didn't talk about today called BIM Plus, which is a really great way to merge all those models into one and then see what's changed. And you can also assign tasks and send that to people and add comments. And so, it's very, there is some work into it because you're going to have to, put them together and see what's there, but we've tried to make it as easy as we can, and we very much believe in communicating with others.
Absolutely.
All right. Next question is, it looked like warping the DTs made those mark numbers unique. Is that correct?
No, actually, as long as those double T's are the same shape, as long as the geometry is going to be the same, as long as the reinforcement is the same, it's going to give it the same mark number. That's not a problem at all. Yep.
Next question, thank you, is what is the cost per seat?
That's a good question, and I think if you're interested in that, let's take it offline and talk about it, because it's probably going to depend on, are you going to do a server? Are you going to do a single license? Are you going to do this, that? We got lots of information on our website. Check that out, and then we'll reach out to you with one of our sales guys and give you that cost.
Absolutely, and it varies too as well per your needs. So the cost can range between different items. So it's best to just talk to us and we'll get you hooked up with everything that you need.
All right, looks like we have time for one more question, and this one is another two-parter. It says, how does your licensing work, and can you have multiple computers access one license?
Yes, definitely. So we do have the option for a server license. So you would put that license on your server, and then multiple computers can access it. It just, the number of licenses depends on how many people can access it at the same time. So we do have that ability. It's really easy, really streamlined. We have lots of different options to network-based, cloud-based for saving your projects. You can also work simultaneously on the same project. So if you have one person working on the second floor and another person working on the third floor, so very flexible there, realizing that in today's world, you need to have lots of options. We have those for you.
Awesome. Well, it looks like that's all the time we have for Q&A. I'd like to remind all of our attendees that if you have any more questions, please send them in and they'll be sent directly to our presenters. On behalf of PCI, I'd like to thank our presenters for their great presentation and all attendees for your participation. As a reminder, a recording of today's webinar will be uploaded to PCI's website within the next week. If you have any further questions, please email marketing@pci.org with the title Online BIM Webinar. Thanks again and have a great day.
Okay, great. Thanks, everyone. Bye.
Yep, thank you very much. Appreciate it.